Hi everybody, welcome to your lesson on formation of the solar system. So before we get started, I want to just kind of recap what we've done so far dealing with astronomy. And we started off with formation of the universe and explored the Big Bang Theory, and then Hubble's law and pieces of evidence for the Big Bang Theory, redshift, the Doppler effect, got into Earth's motion and Kepler's laws of motion, and the difference between revolution and rotation, as well as precession, nutation, and barycenter. And all of that information is going to help us be able to understand the formation of the solar system. So starting off from biggest to smallest, biggest we have the formation of the universe, and now we're moving into, from formation of the universe, different galaxies were formed, and we know that our galaxy is the Milky Way galaxy. And that in the Milky Way galaxy, on one of those spiral arms, is our solar system. So the hypothesis that explains the formation of our solar system is called the Nebular Hypothesis. The Nebular Hypothesis builds off of the word nebula, and a nebula is a cloud of dust and gas. So this hypothesis states that our solar system started as a nebula, as a big cloud of dust and gas. And that nebula started to contract and spin, and that motion created really intense heat and friction in the center. And that was actually considered the beginning of our sun. You can see those rings, those are actually dust particles, solid dust particles. Collisions of these particles, so when they collided, they stuck together, and they kept colliding and they kept sticking together, and that is called accretion. So these repeated collisions accreted to form planets. So many dust particles stuck together to make a bigger and bigger dust ball, essentially, which ended up not being just a dust ball and formed our planet. So you can see in letter D, those pieces of dust are more confined and have bigger pieces. And then in letter E, you see all of the planets that are all going around the sun. They're all revolving around the sun. So our solar system is made up of 8 planets that are broken down into 2 groups. And they're broken up in these 2 groups based on their size, their density, what they're made up of chemically, and their rate of rotation. So remember, they're revolving around the sun, but each of them are rotating on their axis. They don't all rotate at the same rate. So here's a diagram of the planets in order. You have our sun, and then closest to the sun is Mercury. Moving out farther, the farthest from the sun is Neptune. So the planets are broken up into 2 groups. They're in the terrestrial planets and the Jovian planets. And we'll get to the Jovian planets in just a minute. Terrestrial literally means Earth-like planets. So all the Earth-like planets are Mercury, Venus, Earth, and Mars. And these are all really relatively small rocky planets. Here we have Mercury, Venus, Earth, and Mars. As you move across the screen from left to right, you can see that Venus and Earth are most similar in size, and you can see that Mercury and Mars are most similar in size. Mercury is our closest planet to the sun, and its surface is very similar to the surface of Earth's moon. It looks very similar to the moon. Mercury is interesting because it has the greatest temperature extremes of any planet. So during the day, it's really hot, and at night, it's really cold. And that's because there's no atmosphere to keep the heat in or the cold out. Here's Mercury. Surface, again, is very pockmarked. Lots of craters, looks like Earth's moon. Venus is considered Earth's twin because of its size. They're very similar in size, density, mass, and where they're located in the solar system. However, Venus is known for its many volcanoes that cover the surface. So Venus is very fiery. Lots of volcanoes. Earth, of course, is our home, the water planet. Beautiful blue Earth. Mars is known as the red planet because it appears red when you look at it through a telescope. The reason that it appears red is because there's a lot of iron on Mars, and iron it appears red. Possible water on Mars. So I know that we've seen in the news, scientists are actively searching for water on Mars to see if there might, by any chance, be life on Mars. Because with water comes different kinds of life. Some areas on Mars also exhibit drainage patterns that are similar to those created by streams on Earth, suggesting that there once was water on Mars. And here is Mars. Again, it's got a red tint because of all the iron. So the Jovian planets. Jovian means Jupiter-like. These are the outer planets, and these are huge planets that are gas planets. Jupiter, Saturn, Uranus, and Neptune. So here we've got Jupiter from left to right, Saturn with its big rings, Uranus is nice blue color, and Neptune. Jupiter's the giant planet. This is a really cool fact because its mass is 2.5 times greater than all of the other planets combined. It's so amazingly big. You take all the other planets and its mass is 2.5 times bigger. Jupiter has 4 moons and it's surrounded by some rings that are made up of fragments from different meteorite impacts. Here's Jupiter. Very in the middle of Jupiter, you see that spot. That's the great spot. Saturn is known for its intricate ring system. The rings are made up of ice and rock pieces. We've got Saturn's rings. And if you want to take an astronomy class later on or in college, it's really fantastic. You get to go into a lot of detail about what the rings are made up of, what's going on in each of the rings, why the rings are the way they are. You see some variation in the rings. It's really Uranus is the sideways planet. It does not spin like the other planets, but instead it rolls on its side as it rotates on its axis. And this is what, so it spins sideways, unlike all the other planets. Neptune is known as the windy planet because its winds are over 1,000 miles per hour, one of the windiest places. There's Neptune. Pluto, planet X. Pluto is demoted because of its size. Too many other similarly sized objects were found in the solar system that resemble Pluto. So it was either demote Pluto or everything else they were finding that was very similar to Pluto, they had to make a planet. And so they chose, let's demote Pluto because they're all so far away and so small that it's not really significant enough to become a planet. And there's Pluto. And the last part of this lesson is on Earth's moon. So Earth's moon, the hypothesis that explains the formation of Earth's moon is called the giant impact hypothesis. This is the most widely accepted model for how the moon was formed. And it states that when the solar system was forming, a body in the solar system about the size of Mars came in contact with Earth and impacted the Earth. A piece of the debris got ejected into Earth's orbit, so like shot back out into Earth's orbit and then got stuck into place because of the gravitational pull and became the moon. So this is an artist's rendition of the planetary body impacting and then shooting back out to eventually become Earth's moon.